Hello, my name is Tony Cotton, founder of Energy Conscious. We're here today to share our experience implementing a smart DC lighting system that runs over Cat5 cable called LumenCache. This is the third in a series of videos, and this video is on planning and design. Planning is worth the effort. As an engineer with many years of planning experience, I firmly subscribe to the adage, there's never enough time to do it right, but always enough time to do it over. This becomes even more important when you're dealing in completely new technologies. So I set out to research all I could about LumenCache and related technologies. Luckily, we were able to receive a significant amount of hand-holding from the folks at LumenCache, for which I'm greatly appreciative. Our project scope that we discussed in an earlier video was a modest emergency lighting system. We wanted to demonstrate the major features of the LumenCache platform, including energy efficiency, resilience during outages, and automation capability. The results of our experience provided us with a general understanding of the wiring topologies, a detailed wiring diagram using LumenCache's own suggested conventions, and a list of required items and tools that fit within our renovation budget. During my early years as a field engineer, I came to appreciate the adage that experience trumps all, pun intended. For instance, check out this funky combiner clom that we needed to tie 3 switch inputs into a single switch puck port. It's not pretty, but it's functional. Or check out, how do we stuff this SIB into this crowded old metal box? The moral of the story is to add a separate box or mud ring. Don't try to pack things into existing high voltage boxes. We're going to have a much closer look at installation do's and don'ts in the next video. Our first design concept that we had to get our heads around was the various wiring topologies that LumenCache supports. First, we have 2 options to pick from, daisy chain versus home run. In the kitchen, we used a daisy chain topology. And if we look at the diagram, we can see that we have LC0302, which is a home run from the panel down in the basement to light number 2. Then we jump to LC0301, which is light number 1. And then we move on to LC0301B, which is switch 2. And finally to LC0301C, which is switch 2, which completes our daisy chain circuit. Now in this diagram, we can see we used a home run model it's the only home run we used model in the family room. And if we check out the diagram, you can see that we have LC0201 with a home run and no connection between it and LC0202, which is also a home run, and LC02B, which is one of the switches, also a home run, etc., etc. Every device is a home run back to the panel. Now the advantage of the daisy chain is we are using only 1 switch puck port, and we will have a stacked switch puck with a single home run cable. So we've obviously leveraged the ports and we've leveraged the drivers. In the home run, we have every light and switch puck has a port. And if we have multiple switches that need to get into that switch puck, we end up with that funky combiner glum that we looked at earlier. The benefit of the home run is that we're not limited to 2 lights per circuit, and it's reconfigurable. The downside is that it's more expensive. Now we're going to talk a little bit about the difference between a ceiling circuit and a multi-bulb light circuit. The biggest difference is that you have to switch from a constant current driver to a constant voltage driver. Our ceiling lights are all on the constant current drivers, and they can carry up to 2 6-watt lights in a daisy chain circuit that we looked at in the kitchen. Once you get over 12 watts, on a total basis, you have to switch to a constant voltage driver. The multi-bulb, such as what you would have in a master bathroom, you would have to switch to constant voltage drivers, and you just have over an amp at 12 volt. So that'd be just under 15 watts. You could also, if you can keep the load under 15 watts, you could also have an LED strip as long as it fits within that wattage capacity. Otherwise, if either a multi-bulb or an LED strip exceeds that 12 watts, you need an amplifier. This amplifier can support 120 watts, but must be powered over speaker wire versus the Cat5. It will also have a sieve, which still brings control signals over the Cat5, but it'll need an additional line of speaker wire to carry the power. So a single amp could support 2 bathroom light bars with 5 to 6 bulbs each. So 1 amp can pretty much carry a modern bathroom. And the same power considerations would be applied to the LED strips. Only we'll be using watts per foot as opposed to watts per bulb. Next is the location and layout of the structured wiring panel. Ideally, you want this to be at the heart of the house to minimize the cable lengths. Ours ended up in the basement toward the center of the house, and that's okay as long as the basement is completely dry for the electronics. As you can tell from one of our earlier videos, I think it was video number 2, where we actually had shots of the system, you can tell we're new to structured wiring systems. And we assumed that all kinds of mounting options were available. Not. We ended up making up much of our own mounting mechanisms, especially for the power components. And we're going to have more about this in a later installation video. If we had it to do over again, we would completely separate the power from the control in 2 separate panels. And finally, we come to automation. As discussed earlier, we're proponents of open source, whether it be software and or even better, hardware. So we selected the new Raspberry Pi Model 3. It's open source hardware, it's a quad-core processor, it has a full Linux stack. And initially we went with HomeSeer Pro automation software. It's not open source, but it's very open to integration with other devices and software components. Now, even though we started with the HomeSeer Pro, we ultimately had to move, or not had to, but we did move to Node-RED. We're going to have an entire video devoted to automation and why we switched from HomeSeer to Node-RED, so stay tuned for that one. So what are the takeaways from this video? First, we determined which circuits were going to be LumenCache. Not every circuit in the house was LumenCache. For us, we selected them based on what would fill the bill for an emergency lighting circuit. Next, we selected the desired wiring topology for each circuit. Then we had all the tools and supplies on hand. We had accurate and descriptive wiring diagrams. We printed wire labels, and I can't emphasize that enough. And finally, we selected open, compatible automation platform. The time and energy you spend in this planning and design phase should lead to a smoother installation that will serve you well now and in the future. We believe your home can be energy conscious.